Hi guys, hope you are doing well. Today we have come with an interesting topic from your grade 11 gravitation chapter. The name of the topic is mentioned in the page, that is the Kepler's third law, and from this law will be coming to the artificial satellite. What is the orbital speed and what is the time period of the revolution of an artificial satellite? So, why you have come up with Kepler's third law? We can come with Kepler's first law and second law as well. But this third law has an impeccable, has a significant role to understand the artificial satellite and many other things. But to understand the third law, or before going to the third law, I would like to discuss some brief points about the first law and second law. So be patient and stay tuned with us. So, what is the Kepler's first law? What Kepler has told us? That this picture can be a hint for you. The Kepler's first law has states that the planet means it could be Earth or it could be any other planet. Planet which is revolving around the sun can revolve in a elliptical path. That is, it is revolving in an elliptical path, and the sun or the star which it is revolving around, that should be in one of the focus of this elliptical path. It could be here or it could be here. That depends on the time, it depends on the position. So this is the first law. And second law is this planet will cross the same area per unit time. That means when revolving, it will pass the same area. That means this same area in each unit time. That means the aerial velocity should be conserved. Now we are coming to the third law. Now, what is third law? The third law has states that the time period which is the planet is revolving around, the square of the time period. That means if suppose I have taken the time period as t, so the t square of the time period should proportional to the radius. That means the cube of the radius. So what the third law is still, the square of the time period of revolution should be proportional to the cube of the radius, which is it is revolving around the sun. Now there is a confusion. The confusion is, if you know about ellipse and circle, I have drawn two different pictures and they are two different geometrical structures. So if you know about the ellipse as well as the circle, so there is a difference. Can you tell me what is the difference? By seeing the structure, you can see that that is a very oval-like structure and that is a pure circular structure. Now, in an ellipse, there are two axes. One called the major axis, that is the longer one, and one called the minor axis. But here, there is only one straight line, and the straight line is constant around the circular path, that is called the radius. So, when we are talking about Kepler's third law, we are taking the circular path. But as you can remember, the Kepler's first law has told that it should be elliptical path. But why this confusion comes? Why this contradiction comes? So, to understand these things, there are certain assumptions and certain facts which will prove that we can take the circular path as well the elliptical path. Now, what are the reasons or what are the assumptions? Actually, if you know the mathematical aspect of the elliptical path or the ellipse, that means in geometry, there is a term called eccentricity. Actually, this eccentricity is a factor which determines whether this structure will be ellipse or a circle or parabola, hyperbola, any other geometrical, like means curved structures. So this eccentricity, as it is observed experimentally or either mathematically, that the eccentricity of this path is quite less. Quite less means it is quite near to a circular path. So we can take this path as a circular as well to prove these mathematical formulas like t square varies r cube, the Kepler's third law. So we can prove this formula by taking this as a circular path. That means the orbit should be circular, or maybe we can take it as a circular. And for some planets, it is nearly a circular orbit. Not for every planet it is a quite clear elliptical path. For some planets, it is also a circular orbit or circular path. So now we are only taking this circular. That means we are only focusing on circular, not on the ellipse. Okay, so students, learners, please follow on the right side of this page. Now, as we have taken the circular path, so we this actually circle is easier to understand than the ellipse. So now our some task has been easy. So from where we can start? Actually, we have to prove this formula, right? What is t? T is the time period, and what is r? R is the radius. So we have to prove some relation between the time period and the radius. Now, from where we can start? Actually, for the students, it is tough or it is quite hard that, as I have observed, that from where we can start a derivation, or from where we can start a derivation that we can reach to the last final objective, that means final aim. So the solution of this problem is to look into the final aim, that means the final product, that is the t square plus the r cube. So you have to in your inside your mind you have to think about how you can relate the time period with the radius. Now, as you can see, this is the circular path, and you have to relate with mechanics, you have to relate with force, everything. So this is a circular path, and in this circular path it is revolving, means that is a tangential, there should be a tangential velocity v, that is the orbital velocity, that is a linear velocity as well. So as it is traveling in a same orbital velocity, suppose it is v that I have written here, so there should be some forces. In circular path, what is the name of the force? There are two types of force. One is directly inwards, that means the towards the radius, inwards toward the center, and one is the outwards, that means the outward to the center, and both are actually balancing each other. That's why it is a stable circular path. So can you identify which is here the inward and which is the outward force? And first of all, what are they called? Can you recall? Yes, you can. Just little bit you focus on your previous learnings and you can come up with the answer. So the force that is towards, that means towards the center, it's called what? Centripetal or centrifugal? Centripetal or centrifugal, that is the confusion. So tell me, what is the force, centripetal or centrifugal? So please let me know in the comment section. So you please write a comment which is the centrifugal and which is the centripetal, then I can understand that you have understood the previous learnings, or your idea is quite clear about the circular path. We will be coming with the circular motion lesson in future, but I want to check your knowledge about this topic. So please write down in the comment that which is called the centripetal force and which is called the centrifugal force. Okay, so best of luck everyone. Now I am just calling by the name, I am not calling that this is a centripetal or this is centrifugal, I am just calling by inward and outward force. So here what will be the inward force? Now the inward force will be the attraction force, and in gravitation, what is the attraction force here? That's the gravitation force, right? So this should be the inward force, should be the gravitation force. So I'm writing the gravitation force. Okay, so gravitation force, we all know from Newton's gravitation law that g m1 m2 by r square. Suppose I am taking the mass of the sun as m0 and the mass of the earth is m, small m. Okay, we can take also ms as mass of sun, me as mass of earth. That depends on you, that what you can take, that is up to you only. But I am taking these things. So the mass of the sun I have taken m0 and the mass of the earth I have taken small m. Now what will be the force then? G m1, then that means I have taken m1 as m0 and m2 as small m, by the distance between their centers, so that is the r square, that means the radius r square. Now we have to balance the force with an outward force. What is the outward force here? Now you have to remember the formula. I can derive the formula of the outward force, but it will take time. Okay, the video is almost it is beyond 10 minutes, so I will not take so much time. So I am writing on behalf of you, that is the mv square by r, right? So in comment you write what is the mv square by r is called, and what is the gm m0 m by r square is called. That means the inward and outward force. That is your task only. Now I have to balance these things with it, so it will be mv square by r. Now this formula should be simplified. Now which are the things, which are the terms will be cut it? Small m will be cut it from the both side. Also 1r from the right side will be cut with the 1r with the left side. So only 1r will be left in the left side. Now I only writing in terms of v square. V square should be what? G m0 by r, right? G m0 by r. So just I am writing as, suppose I am taking v square equal to like this. So I am not taking, okay, let me take v equal to, so v equal to what will be? Root over, it was square, so it will be root over g m0 by r. So now just leave these things. Okay, now you are thinking about, so I have just taken the formula v, or the expression of v, but what is this related with the time period? Now we are talking about time period, that means time. So time and velocity are related, that you have to know. That is the quite simplest mechanics actually, how the time is related to velocity. So how the time is related to velocity? The time and the velocity. Now we all know the velocity is equal to displacement by time. Or if I can take only the speed, if I am not going to the vector scalar debate, I am just taking as the v is speed. So speed should be equal to distance by time, right? So speed, that means v should be equal to distance by time. So here for this path, what is the distance in one full cycle? That means one full revolution. What will be the speed, what will be the distance it will travel? Distance means the circumference of this circle na? It will just cover one circumference. That means what is the formula of circumference of a circle? That is 2 pi r. You all are right. Now this is the distance, so speed equal to distance by time. So what will be the time? One revolution means one time period, just only the time period, 2 pi r by t. Got it? Now the thing I'm writing, only t equal to how much will be 2 pi r by v. So v will be coming like this crossway. Now we have determined the v, understood, but there is a short way of directly coming to the last destination, that there is t square, that is t square. So in my mind I will just know that I have to do the square, so I am doing the square. So I am doing the square, so both side I am doing the square. T square equal to c 4 pi square r square by v square. Can you see? Can you see this? Can you see? Yes. So v square I have already determined, gm0 by r. So t square equal to how much? 4 pi r, 4 pi square r square by v square means gm0 by r. So this r will go to the up, and it will be surprise, it will be r cube. That is right, you are all correct. So it will be 4 pi square, in the down in the denominator it will be gm0 only, and r cube will be only. And we can say that this is a constant, right? This is a constant because 4 pi, everything is constant. gm0 is also constant. G is the gravitation constant, and m0 is the mass of the sun. Everything is constant. Pi is the constant, you will all know. So t square we can say varies r cube. Now we have come up to the destination. See, we have proved, and it was quite easy, na? It was quite easy. You all can prove now these things, but do not forget to comment. Do not forget to comment any other ideas you have, or any doubt regarding this derivation. You can tell me in the comment. But the foremost task, or the sincerely you have to do that, what is the inward force and the outward force called in circular motion, which is that means which is the centripetal force and which is the centrifugal force. Okay, now we are coming to the satellite. Okay, we are coming to the satellite from this concept, from Kepler's law. Now, if I take, suppose, if I take, I'm just drawing here. Okay, don't go with my drawing because my drawing is not that good. You can do better. So, okay, so believe in you, you can do better. Okay, I am just here to demonstrate you. Now, just focus on the left side. I am drawing here. Okay, so I am taking the earth here. Okay, if you can just um, check whether it is a earth or not, but I am showing that it for a earth. So I am taking one orbit of earth. Okay, one orbit of earth. Okay, so it is quite near to the circle. Okay, don't judge my painting or judge my drawing. Okay, so suppose I am drawing, okay, and rough diagram of a satellite. Okay, this is a satellite you can take. Okay, this is satellite. So just as a rough diagram, schematic diagram. So the thing is, we all know the radius of the earth. Suppose it is capital R I have taken. And now I am taking the radius, sorry, the radius, or the, I can take the distance of the satellite from the earth's surface is it's h. It is in a h height, and I am taking the whole radius, that means the radius of this satellite na, smaller. So I can write small r equal to capital R plus h, or not. Just tell me, can I write this small r equal to, because capital R is the radius and h is the distance of the satellite from the surface, right? So we can take this. You can take this. Now I'm taking these things also. I am taking the velocity of the or the orbital velocity of the satellite called v0. Okay, I'm taking it as. So same way we have to come from this. We have to come from this. Okay, so same way. How can we come? Now check it. I can write, like, suppose I am taking the mass of the satellite at small m and the mass of Earth as me. So same formula, g me by small m by which one will be which r square? Only capital R, only h, or whole both smaller. So this should be the distance from between the satellite and the earth. So that means the whole r square. Now it should be equal to what? Same. That means the outward force, that is the mv0 by mv0 square by r. That means same way. The terms are different only for this case. So actually they all are following the gravitational law or gravitational field or gravitational force. So the same things. The concept is same. More or less the concept is same. So it here will also same. The same things will be cut it. That is the same thing. So I can write the same way, g me by r. You can see that these two formula, this formula, okay, and this formula is coming up in the same way, same type, same form, but the only difference is here is the m0, that means mass of the sun is there, and here is the mass of earth, that means the center particle around which the other particles are revolving. That is this thing. Okay, that is the thing. Now I am writing GME by small, in the place of smaller, I can write this one, R, capital R plus H. Right? You can write that. You can write. Okay, I have written. Okay. So, sorry, it should be V0. That my mistake. So, V0 is equal to how much? So, square will be that, in that side it will be square root. So, G small m e by R plus H. So, that is the formula of the orbital velocity of an artificial satellite. Also, you can measure the orbital velocity of natural satellite of Earth. Which is that natural satellite of Earth? You all know that is our moon. Okay, that is our own very dear moon. So that we can also. So in this way, actually, we are following the same method, the same way, same formula, same thing for both the cases, for all the cases actually, right? And also we can determine the time period of revolution of this satellite, like the same way, same. That means v0 I'm writing here, okay, you can see here from here. Sorry for this arrangement, okay, but just be patient with me. v0 equal to how much? Same 2 pi r by t, same t equal to 2 pi r by v0, right? Now I'm just writing in terms of 2 pi r by v0, I'm writing only 2 pi small r by root over g me by small r. I'm not writing r plus h now. Why? Because in the numerator there is small r. Also I have to write the small r here to simplify the things, okay, not any other reason is there. So the thing is, okay, just look here, just look here what I am doing. So as you can see, I can write this way, 2 pi r root r. I am taking the root r, this root r in the above, and there should be root over only gme. Okay. So I can write this way also, 2 pi by root over gme, and I can write r root r as r to the power 3 by 2. That is a mathematical thing. That is a mathematical thing. So as you can see, if this formula is correct, so t square is varies as r cube. So I can write t varies as r to the power 3 by 2. Nah. So here you can see that this r to the 3 by 2 is coming. So that means t is equal to 2 pi by root over g me r to the 3 by 2. So it is also obeying the Kepler's third law, na? And we are coming in the same way. That means we are coming from the third law actually. The actually not coming from the third law, the concept of third law we are coming. So you can see that. You can see. So you can calculate. From here also you can calculate the mass of the earth if you know the T and R. Right. So everything. If suppose the satellite is moving very closer to the earth, so I can take in that case R R is really greater than H. That means I can take R plus H is equal to only R. We can neglect the H because it is very quite small. The H is becoming small now. So the formula will change accordingly. Also we can, if you don't know about the mass of the earth, if only you know about the rate, about the density, so you can convert this mass into density. That I am not sharing in this video because this video is very long, okay. So it is already very long, so I'm just ending here, okay. Hope you guys have understood. Okay, hope you guys have understood, and it is quite clear to you. And in future I'll coming up with some extra ideas or extra content regarding this Kepler's third law and artificial satellite. Okay, so keep stay tuned with us and keep supporting us, so whether we can give you some very interesting and very useful content in future regarding the physics. So this is about the class 11 grade 11 gravitation chapter, and especially the Kepler's third law and artificial satellite. So see you again in the next video. So still till now you just enjoy yourself and be in study. Thank you.